Okay, now we're heading toward LU decomposition. We start with a familiar matrix. We know this matrix is non-singular. We've reduced it before. And we're going to invert this matrix using elementary matrices. Do a complete reduction using elementary matrices. Now, LU decomposition is somewhat simpler than that, but let's just go ahead and get good with these elementary matrices. First step in reducing the system, add -4 times the first row to the second. The elementary matrix that adds -4 times the first row to the identity is this. The matrix that undoes that adds 4 times the first row to the second, and elementary matrix, so the inverse elementary matrix is this. Multiply by the elementary matrix, and we get this matrix. This matrix, step in the reduction, let's make that a 1. Divide or multiply the second row by -1/16. If we do that to the identity matrix, we get this. And of course, the thing that undoes that is to multiply the second row by -16. And if we do that to the identity matrix, we get this. So here's our inverse elementary matrix. Here's our elementary matrix for this step. Multiply the elementary matrix by the matrix that we got. Now the matrix we got here is our matrix E1A, E1 being the first elementary matrix, A being this. So the elementary matrix we're using now is E2, and we do E2 times E1A. We get this. Now, next step, we're going to want to get rid of this 2. Okay, so we're going to add -2 times the second row to the first, replacing the first row. We're going to get the identity. Using elementary matrices, add -2 times the second row of the identity to the first, and we get this matrix. The thing that undoes that, add 2 times the second row to the first. Okay, so here's our third elementary matrix, E3. Here's the inverse. We have determinants. Determinant is 1 here, determinant is 1/16 here, determinant is 1 here. Determinants over here are 1, -16, and 1. Okay, having done this, we see then that what we get in the end is just E1 times E2 times E3 times E2 times E1 times A. E1's the first matrix that multiplies A. It has to be next to A. If you had it out here, matrix multiplication isn't commutative. It wouldn't have the same effect as what we did. And then you multiply that by E2, and you multiply that by E3. Now, we see then that if we do this multiplication, E3, E2, E1 multiplied by A, we get the identity, which means that E3, E2, E1 is the inverse matrix. Furthermore, if we do E3, E2, E1 multiplied on the left by E1 inverse, E2 inverse, E3 inverse, the E3 inverse pairs with the E3 to give the identity, giving us this, and these two give us the identity, giving us this. These two are the identity. This matrix is A inverse. Well, this times this is the identity, so this must be the inverse of A inverse, which is A. Okay, so that's all pretty interesting. But we want to go to the LU decomposition, okay? And that uses a lot of the same stuff, but not all of it. First of all, let's just note that the first upper triangular matrix we get in the reduction comes right away. Okay, this is an upper triangular matrix, so this is a perfectly good upper triangular matrix. Now, if we multiply this matrix by the inverse of our E1 matrix, because this is our E1A matrix, if we multiply this by E1 inverse, we'll be back to here. So that E1 inverse, this matrix, multiplied by E1A, which is this matrix, and here, gives us E1 inverse times E1A, which is A. Now E1 inverse, we notice, is lower triangular. All these matrices, well, not all of them, but E1 inverse is lower triangular. Okay, so we have a lower triangular multiplied by an upper triangular, and that's equal to A. So now A is a product of E1 inverse with E1A. This is lower triangular, this is upper triangular. Here's the matrix A. It's this lower triangular matrix multiplied by this upper triangular matrix. Now we could have, if we preferred, used this for our upper triangular matrix. And this comes from first multiplying our A by E1 and then multiplying that by E2. So if we wanted to do that, we have E1, E2, E1A is this upper triangular. Well, if we multiply then by E1 inverse, E2 inverse, we get the matrix A. And E1 inverse times E2 inverse, multiplied out, we get this. So now A is the E1 inverse, E2 inverse, multiplied by E2, E1A, which is this, and that's a lower upper. Okay, so this is lower triangular, this is upper triangular. We could use either of these. Now we're going to relate this to, now we're going to do a little bit more with one of the systems we've already seen, employing some elementary matrices, and then we're going to just do an LU decomposition, a solution of the same matrix system using LU decomposition.